Okay, in geometry notes, number 18 is proved lines are parallel. Make sure to put your name, date, and class period, please. And then your essential question is, how do you prove lines parallel? And the answer is, to prove parallel lines parallel is by showing that corresponding angles or alternate interior angles or alternate exterior angles are congruent, or show consecutive interior angles are supplementary, and those will prove lines parallel. Here I have postulate 16, corresponding angles converse. Remember, the converse goes the other way. So on the postulate and theorems we're doing today is that we're trying to prove lines parallel. The ones we did the previous day proved angles congruent, so these are going backwards. So as you read them, it says two lines are cut by transversal so that the corresponding angles are congruent, then the lines will be parallel. Or if you have lines cut by a transversal where the alternate interior angles are congruent, will cause the lines to be parallel. Or if you have the alternate exterior angles congruent, then the lines are parallel. Or if you have the consecutive interior, which remember is the same side interior, are supplementary, in other words they add to 180, that causes the lines to be parallel as well. So you have to keep in mind that these are the converses for your proofs that you're fixing to start having. Okay, example 1, it says find the value of x that makes these two lines parallel to each other. Well, if I look at my equations here, I notice that they're on the same side. That means these are corresponding. And if I use the postulate, it says that these two things have to be actually congruent to each other to show that they are parallel. So I'm going to do 7x plus 4 and set it equal to the angle measure of 53. So here's a two-step problem. I'm going to subtract 4, and I have 7x is equal to 49. I'm going to divide by 7, and it tells me x is, x is 7. Okay, on example 2, it says, is there enough information in the diagram to conclude that G is parallel to H? G being parallel to H. So I'm looking at what is given to me. I notice I have 110 and a 70, and these are same side exterior angles. And looking at that, I need to know that same side exterior angles are similar to same side interior in the fact that same side exterior are supplementary angles. They're supplementary angles, and therefore they will add to 180 degrees. If I look at these two angles, I have one that is 110, the other one is 70. They both add together to give me 180 degrees. So yes, there is enough information, and my explanation is same side exterior angles are supplementary. Now if you want to use the proper word here, this will be consecutive exterior angles, or you can just stick with same side exterior angles. Okay, if I look at my next diagram, notice I have three lines here with several different expressions. On A it says find the value of x that makes A and B parallel. If I look at A and B, I have two angles given to me. They're on the same side interior, so that means they are consecutive interior. Or you can just have same side interior, but we know that those angles have to be supplementary. Therefore, I'm going to take the 62 and add to it the expression that I believe I put my pen on there. I believe that was 5x minus 2 and set it equal to 180. Well, that, I'm going to squeeze it over here so I have room to write. That will be 5x plus 60 is equal to 180. I'm going to subtract 60. That'll be 5x is equal to 120. I'm going to divide by 5, and that tells me x is 24. Alright, if I look at B, it says find the value of y. That makes A and C congruent, or it makes A and C parallel. A and C, these two angles here, are alternate interior angles. That means they are going to be congruent to each other. So I'm going to do 62 is equal to 7y plus 6, and I want to solve it. If I subtract 6, that gives me 56 is equal to 7y, and then I'm going to divide by 7. That tells me y is equal to 8. Okay. On the back of that page, I have one more theorem that I almost forgot to put in here. Theorem 13 is transitive property of parallel lines, and that's looking at this example we had here. Said that A was parallel to B and B is parallel to C, therefore A is parallel to C. That's still the transitive property. It exists for parallel lines. And then example 4 is a proof that I'm going to go through because you have that on your homework. Remember, the first one will always be your given, and that satisfies the first one, but also have a second one that says angle 1 is congruent to angle 2, which is actually on number 3. So I'm going to go ahead and put the given on number 3. But I'm going to look at the fact that it says G is parallel to H, and the next step is saying that angle 1 is congruent to angle 3. Well, 1 and 3 are what kind of angles? Okay, those are corresponding angles. And realize they're asking that the angles, we're given that they're parallel, and we're asked what the angles are, so that means this is the corresponding angles postulate. Okay, corresponding angles is always the postulates. Then we're given that the given is saying that 1 is congruent to 2, and realize there is no relationship between them whatsoever, saying 1 is congruent to 2. But here it has on step 4, 2 is congruent to 3. If I look at above, it says that 1 is congruent to 3 and 1 is congruent to 2, so 2 and 3 are both congruent to the same exact angle. Therefore 2 and 3 have to be congruent to each other. Okay, so this, in a strange form, since they're all dealing with angles and there's not any numbers, this is our transitive property. Of angles. This is our transitive property of angles. Basically, they should flip-flop the 3 and the 1 around to actually get it in the correct order that we have, but it's okay the way it's written. Therefore, we can say that P and R are parallel because we're saying the angles are parallel. I'm sorry, the angles are congruent. We're going to a parallel. That's involving our converses here. 2 and 3, these two things are called what kind of angles? Well, these are also called corresponding angles. But because we're going from angles to lines, this involves the converse. Which your converse said you have two lines cut by, if the corresponding angles are congruent, the result is the lines are parallel. So this involves the corresponding angles converse. That's very, very important. Whoops, I wrote converse first. Corresponding angles converse postulate. Okay? And that is very, very important. You understand the difference in corresponding angles postulate and corresponding angles converse. And it's all in the if-then statement. If you have parallel lines, the result is congruent angles. Or if you have congruent angles, the result is parallel lines. Very, very important which way you go. Okay. Your password for the notes today is going to be the name of my dog, which the name is Dusty. Here are your independent practice problems. I want you to work them out. There's just 4 of them, and we'll go over them first to class. Make sure you answer your summary so I can pick up your notes immediately.